Okay, so here's a test of the Eltako ESR12Z relay mode versus Teleruptor. We're going to use the PFC 200 for this and start off by making a new project in eCockpit. Once that's loaded, we're going to scan the network for the PFCs that we've got connected. There's two of them on this network, a 8202 and 8204. We're going to scan the 8202, check its modules, apply the selection, and then we're going to rename one channel of an output module to DOO source, because it's a source output, and the digital input we're going to call DAI10 sync. So then we're going to rename the default PRG POU to PRG bistable. This is going to be the Teleruptor code, and then we're going to add another POU program, and that's going to be our code for the regular relay mode. And finally, we set the scan cycle of the PLC to 200 milliseconds for this task. We're going to start with the Teleruptor modes, bistable relay, so we have to set the dial of ES, and we're going to go for 4 times S, which means there's 4 channels on the Teleruptor, and all 4 of them will work independently. For the bistable relay, the code is very simple. We're simply going to assign the value of the sync input to the source output. We'll compile that, build, and then we'll connect up to the PLC, log in as administrator, and run the program. Unfortunately, in bistable relay mode, there's no direct feedback to the PLC to know what the actual status of the bistable relay itself is. If we want to get some form of feedback, we have to switch over to normal relay mode by turning the dial to ER. We can leave the 4 times R setting at the bottom as it is, that the bistable relay will now simply operate as a regular relay with 4 independent channels. We're going to use a rising edge function block here, which will detect any incoming pulses from our switch. We're going to link the trigger to the digital input sync we defined earlier. Next, we're going to use the following logic diagram here. This is essentially a exclusive OR diagram between the output and the pulse trigger.